Assalamu alaikum warahmatullahi wabarakatuh. Dear students, uh, we are here back, Dr. Ali El-Moursy, for the microprocessor classes, and we have finished in the last lecture how can we use the conditional jump instruction and compare in order to implement a while and do while loops. Today is this lecture is lecture number 20, part 1. Lecture 20 part 1 will talk about the conversion or the implementation of the if-else statements in the assembly. Again, using the exact same set of components that we have or tools. So here we have to pay special attention about the high-level language and how the if-else statements are working. There is a kind of an opposite intuitive concept here in the if statements. In high-level language, we have what's called the if statement. Okay, so for instance, if and I have some condition, okay, I usually have brackets, and I have some code A that needs to be executed. Okay, first we will start by the simplest case, which is only if statement, even without else. Okay, and we may have code for B after the if statement. Something that we need to pay attention here. So for the if statement, okay, I have if and the condition. Again, I have to reflect here. If the condition is true, I need to execute or perform execute code A, then code B. This is actually what I want to do. Okay? If the condition is evaluated to be false, I will not execute A, and I will execute only the code for A for B. Okay? So remember here, this condition can be checked, okay, through the compare instruction. So I can use the compare instruction to check for the condition. I can use the compare instruction to check for the condition. If the condition I'm using compare and the pair of instruction compare and the jump. Okay. Now, if the condition is evaluated as true, okay, shall I check here for the condition to be true? Remember, if I want to follow the same sequence of code as the original one, so that means the code which comes after the conditional jump, okay, should be for the code. So if I decided to have the code for A here, that means I don't want to jump. I want this to be executed, okay, when the condition is evaluated to be true. So that means here I have to say the opposite condition, or the label for the opposite condition. Not the label, I mean the opposite condition. I have to use the opposite condition, because if a jump is evaluated as true, it will jump. Here, if the if statement evaluated as true, I want to execute A, okay, which is exactly the opposite. Okay, so that means here, if the condition is false, I want to jump, calculate, go to the calculation for B. So if I have here code for B, okay, when the condition here is false, I want to go directly to B. I want to skip A, which match with the jumping. If this is evaluated as true, I need to jump to B. Okay, so I have to use here the opposite condition. Okay, right. Let us discuss a practical example for this. Okay, assume that I have, so this is the general skeleton. Okay, by the way, before we go to, there is actually another implementation for this, through which I have to swap those. Okay, but let us take an example for this before we go to the other implementation, not to confuse you. Assume that I have some variable x. X should be equal to some constant. Okay, let's say that this constant is called C, whatever, some constant C. If x equals to C, I want to execute A and then execute B. That means here, my condition, if I want to check, assume that AL equals to the value of X. Assume that in the assembly, I already loaded X into AL register. So I will compare AL with the value C to check for this condition. Now, in order to write the instruction here, which equality instruction I want to check? If AL equals to C, okay, the jump will jump to B. Okay, if AL do not equal to C, that means I want to jump. So that means here I use jump if not equal to code B. If it is not equal to code B, okay, that means that if they are not equal, that means I want to go directly to B, similar to this. Right. If it is equal, that means the jump will not be executed and the code will continue. So code for A will be executed and followed by the code for B. So pay attention here. If I want to implement if statements, and the jump should be used in the negated logic, the opposite logic. Because if this is true, I want to execute what comes next. But here it is the opposite. Okay? Why it is the opposite? Because if those are equal, that means I want this to be a performance. So if they are equal, I want to continue. Okay? So if this is equal, so that's why here I put A. If these are not equal, means I will jump. If they are equal, means I will continue and execute A, then B. Right. That's why I have more, the option one. The option, this is option number one. Can I write the code differently without having this negated logic? The answer is yes. But I have to reorder my code. In the assembly, I have a second option to write the same assembly code. Here I have to first also compare between AL and C. And then I want to jump if equal. If they are equal, what shall I do? If they are equal, I want to execute A, then execute B. Okay? So if they are equal, okay, I want to execute the code for A. So I have to have code for So if they are not here, if they are equal, I will jump for A. So I will have code A. That means here at label code A, I will have my code. Now, if they are equal, I should execute A, then execute the code for B. So at the end of code A here, I have to use unconditional jump to jump. I have to jump for code B. So that means if they are equal, I will go execute A and then jump to execute B. But if they are not equal, I want to go to execute B directly. So now, right after the jump, I will have code for B here. So that means if they are not equal, I will not jump for A, I will execute B. But after executing B, the high level language tell me you have to skip the code for A. So I cannot leave the code for B followed by the code for A, because this means automatically, okay, I have it will actually execute. So I have to have here also another jump. Maybe I can have here this I will have here I have the rest of the code, and I have maybe here a jump for whatever, for what's after B. Maybe here a exit. Okay, so I will have here a jump to exit. Okay, exit will be here automatically. Here I have exit. So code for B then exit here, code for B then exit. So here I have to jump for exit to avoid that code for A executed after B. So these are two different implementations for the if statements. Either do it with the same sequence of code as the high level language, but you have to negate the logic. If you want to use the straight logic here, so you have to maneuver the order of the code for A and the code for B. You have to swap them, okay, in order to guarantee that if this condition is true, I will execute A, then jump to execute B. But if they are not equal, that means I will only execute the code for B. Okay, here, if not equal, we'll go for B. If equal, I will go for A, and automatically we'll go for B after A. Okay, so the code will be kind of more healthy or more straightforward. Okay, so this is when I have only if. If I have if else, again, I may have different scenarios. So that's why let's go now to the slides in order to demonstrate the if else. We have in the slides an example for the not only if, but if else. So let us go back to our slides here. So this is actually slide number for the if else statements. It is slide number 38. In slide 38, you can find here at your left hand side, you have some condition for x equals to 10. Okay, I have inside the if brackets, I have code for A. In the else, I have code for B. And outside the if else, I have code for C. So in order for this code to be written in the same order, so I will have a comparison between the memory location at X and the value 10. Then I have jump if not equal, so go directly to B to execute the else. So here actually this is a representation for going to else. So if they are not equal here, I want to go to the else. So if they are not equal, I will go also to the code for B. Okay, if they are equal here, I will go directly to A. So if they are equal here, that means the jump will not be executed and A will be performed. After code for A, I will not execute B. I will go to C. So that's why here, when I finish A, I will jump directly to A to C. If I will go to B, here I should execute B, then C, and here also I will jump to B and then execute C. Okay. So here, in order to make the if-else statements, I need the help of the conditional jumps and the unconditional jumps in order to have a code healthy that actually implement the same logic as the if-else statements that exist in the high-level language. Okay, so this actually the lecture number 20, and which actually describes the if-else statements. This is 20 part 1, and inshallah in 20 part 2 we will discuss the last part, which is about the switch cases. So thank you, and see you in the next recording for 20 part 2.